I hope your work in trigonometry is going well. This week in trigonometry, we're playing with the idea of sine, cosine, tangent, and other trigonometric functions as functions, which means instead of pulling the graph and thinking about them on the unit circle as x values, y values, or slopes of the radii at those angles, we'll instead take a look at the independent variable versus the dependent variable on a pair of perpendicular axes. So in this case, the independent variable for, say, the sine, that's the angle, versus the y value. What happens when we look at the angle versus the y value on its own outside of the unit circle? So not too bad. If the angle is 0, the y value on the unit circle is 0. So we get that initial point for the sine. It's going to be 0, 0 on an axis theta versus y. And then if we move out toward pi over 2, in between we have pi over 4, and each side of pi over 4, we have pi over 6. And again, they aren't equidistant, and pi over 3. So if we graph just the y value versus the angle, then we're going to have a peak y value at pi over 2 versus 1 for y. And then we're going to increase toward that. So at pi over 4, square root of 2 over 2 is about 0.7-ish. So if that's 0.5, 0.7 is around there-ish. So we should get a point around here. And at pi over 3, let's see, no, pi over 6, it's 1/2. So that's going to be around here-ish. Come on, point. And at pi over 3, the y value is square root of 3 over 2, which is almost 0.9. So that's going to be up a bit higher, like right there. And so we have this arc toward that maximum there. And then as the unit circle comes around this way, those y values are going to start dropping again. Square root of 3 over 2 for y, square root of 2 over 2 for y, 1/2 for y, down all the way down to y equals 0. So as we get over to pi, those y values are going to drop. And then on the third quadrant, those y values are similar to these up here, but negatives. And the farthest away y can be is -1. So -1 is going to be around here. So I went from 0 to pi over 2, then pi over 2 to pi, and pi is going to hit us over to 3 pi over 2. And that's where we're going to bottom out at the bottom of the circle. So that sine here on this graph is going to terminate there. And then we're going to head back up till we hit our 0 again, and we'll get a complete wave for the sine. So again, knowing the unit circle helps view the sine and cosine as these waves in a different coordinate system. Take a quick look at Desmos with that. Get a quicker graph. Call this f of x equals the sine of x. So again, we can see this wave. Now notice the shape of this wave. That is not a semicircular shape. It's a whole new curve. That curve is part of a sinusoidal function. And I have my peak at pi over 2, 1. We have another 0 at pi. We started at a 0. And we have our minimum at square root of 3 over 2, -1. And then we complete one cycle at 2 pi. So this is a periodic function. So what that means is after a certain amount of distance on the independent variable happens, the y values get repeated. And so we can see the sine has a period of 2 pi. 2 pi. Cosine, similar, but starts at a different place. If we look at g of x equals cosine of x. And again, on paper, I'm calling it the independent variable theta, but Desmos will only accept x as the independent variable. We can see the cosine wave in blue here looks much like the sine wave. It's just shifted. So here we're starting at the maximum, and then we drop toward the minimum and then back to the maximum. So from the maximum point to the next maximum point, we do one cycle of this, one period. So again, the cosine is a period of 2 pi. Think about the tangent for a moment. So with the tangent is y over x on the unit circle, which is the slope of each of those radii. So I'm going to put the slopes up here in red. Y over x, 0 over 1, the slope here of that radius is 0. Slope here, y over x, which is 1/2 over the square root of 3. The halves divide out, so we're going to get 1 over the square root of 3. The slope at pi over 4 is the same number divided by itself, so that's a 1. The slope at pi over 3 is going to be square root of 3 over 2 divided by square root of 3 over 2. The halves divide out, it's going to be the square root of 3. And then the slope over here, well, that's a vertical line. It's got no slope. What does that look like? So if we think about the tangent for a moment, and we try to graph the angle versus the value of the tangent at that angle, we're going to start off with a 0 angle, has 0 slope. And then if we go to pi over 6, we're going to get a slope of 1 over the square root of 3, which is about 0.8-ish. So let's say that is about 1 there, and that's about 2 right there. So at pi over 6, the slope's around that. At pi over 4, it's 1. So pi over 4 is about here. Oops, that's a 6. Slope of 1 is going to be around there. Pi over 3 is going to be about here. And square root of 3 is about, let's see, 1.6, 1.7-ish. So that's going to be somewhere over here. And then at pi over 2, which is about here, we're going to get 1 over 0, which is a vertical asymptote. So this tangent function is going to rise up through those points, and then it's going to go asymptotic. On the other side, we're just going to have the opposites of those slopes, and so a similar thing is going to happen on this other side. And so at negative pi over 2, we're going to get an asymptote. If we take a look at this on Desmos to see what's going to happen outside of the interval from negative pi over 2 to pi over 2, let's turn these guys off and look at the tangent. Let's call that h of x. What's the tangent of x, which in Desmos you can get by typing it, or if you're on a mobile device, you can choose from the function menu. By default, on the Desmos graphing calculator, you are in radians. You should be working in radians unless you're specifically giving a degree value to plug in. By default, we're in radians here. I recommend keeping it that way. So again, I believe, based on the unit circle, that there should be vertical asymptotes at x equals pi over 2. And also there'll be another one at x equals negative pi over 2. So the distance from negative pi over 2 to pi over 2 is a distance of pi, and notice the tangent keeps repeating that same pattern over and over again. So unlike the sine and the cosine, whose periods are 2 pi, the tangent is periodic with period pi. Other things that you should be familiar with. So again, unit circle is super important. What the graph of the sine and cosine look like. Where are their zeros? What are their periods? What's the graph of the tangent? What's its period? Where are its zeros? Where are its asymptotes? You should know a little about transformations of functions. So if we're just looking at sine or cosine, we can transform it by multiplying inside by the independent variable, by adding or subtracting to that independent variable, by multiplying something by the y value, the dependent variable on the outside there, we're adding to the y values some value. Summary of what these mean. The value of a is important because it tells us about the period, and the period can always be found by taking 2 pi divided by a. Similarly, if you know the period, you can solve this equation and calculate a. Value of b is called a phase shift, the shift left or right. So for example, the cosine can be viewed as a shift of the sine. If we look at those two graphs, let's turn some of the other ones off. So the cosine is in blue, the sine is in red. And if I were to take that sine and shift it left by pi over 2, then I would get the cosine. You think back to the function transformations back in Precalculus 1 or college algebra, it would look something like this. The cosine of x is equal to the sine of x with a shift. The shift has to be pi over 2. If I want that shift to go to the left, then I would do a plus pi over 2 there. So if you compare those two graphs, they should look the same. Similarly, I could go the other direction. I could take the graph of the cosine, the blue one, and I could shift it right pi over 2 and get the sine. Sine of x could be equal to the cosine of x, and I want to shift the cosine right to get to the sine, so that'd be minus pi over 2. You can check that out on your calculator. Other important values here, the c out front tells me about the amplitude, the height of the wave. From the midline. And d is the midline. So whatever d is, if I'm using a sine, and this is the y-axis there, d is the midline, and the amplitude is the distance from the midline to the peak, or that amplitude is the distance from the midline to the minimum. All right, that's it for basics and trigonometric functions, that is. I hope your work is going well. And I hope that you have the unit circle, at least that first quadrant, memorized at this point, and then how the sine, cosine, tangent, other trig functions are related to each other. Get in touch if you have any questions. Keep up the good work. Do good math. I hope to see you or hear from you in the near future.